Hey everybody, it's Mr. Carr again. Today we're going to be looking at 2.1 day 2. More graphing of our quadratics, but now we're going to do a different format of it. It's called vertex form. This is what vertex form looks like. It gets its name because it tells you a little bit what the vertex is. A times x minus h squared plus k. The vertex in this format is always the h and k. So axis symmetry, remember we talked about this before, is that the value here has to match up to the x coordinate there. So that's why the axis symmetry is x equals h in this case. Notice again, this is very similar to when we did our absolute values. Absolute value was a times, it looks like this, was it? A times the absolute value of x minus h plus k. It's the same job. A, h, and k do the same thing. So just like before, where we said that it was opposite this negative h, it turns into a positive h, same thing happens with a quadratic. This is a negative here, it's going to be a positive in the vertex. If this was a x plus h squared, then my vertex would be at a negative h, and then whatever k is. Okay, so that's something to keep in mind because now we go to our graph like this. So finding some of those information is honestly, pretty quick and easy. Where's the vertex here? It's based on just these two numbers. So my vertex is going to go opposite the positive 2, so make it a negative 2, but then it goes the same as the positive 5, so it's going to be right there. So I plot that there, I go negative 2, positive 1, 2, 3, 4, 5. Here's my vertex. Does the parabola open up or down? One thing causes that, and that's the negative sign in the front. This is going to open down. So it looks something like that. Is it vertically stretched, vertically compressed, or neither? So if I ignore the negative sign, I notice there's a 1/4 in the front. That is going to be vertically compressed here because 1/4 is less than 1. Well, now I can kind of do some of my graphing here. First thing I'm going to do is, I got my axis of symmetry. Just like before, I just want to find one other point on the graph. Then I can just do my symmetry part and I can find a third point, and then I can just connect all 3 dots. So pick something easy. Yeah, the y-intercept actually is pretty good here. The y-intercept I'm going to find by doing, running out of space. Let's do this. Just add a little bit of space here. Come here like this. So it was y is equal to a negative 1/4 x minus 2 squared plus, or x plus 2 squared plus 5. So y-intercept I could always find by plugging in x equals 0. So I don't see the y-intercept in this equation like this, but I can find it pretty easily. So if I do y is equal to a negative 1/4 times 0 plus 2 squared plus 5. Okay, 0 plus 2 squared is 2, or sorry, 0 plus 2 is 2, 2 squared is 4, so this turns into a negative 1/4 times 4 plus 5. So y is going to equal to, when I multiply these together, a negative 1 plus 5, which is going to come out to a positive 4. This tells me my y-intercept, which is the point 0, 4. So that tells me I can do this. I go 0, 1, 2, 3, 4 right there. And again, thanks to symmetry, if this is 2 spaces to get to my axis of symmetry, I can go 2 more spaces right there. So here is my graph. Again, all I need is 3 points. If you want to be more accurate, go ahead and plug some more in, but 3 is all I absolutely need. All right, let's do another one. So we'll sketch this graph. Where's the vertex here? We have negative 5 and negative 1. So that tells me it's going to be at a positive 5, negative 1. So I go 1, 2, 3, 4, 5, negative 1. Okay. Does the parabola open up or down? Because this is a value of a positive 2. So it's positive, meaning it opens up. So we're going to go look like that for its parabola. Is it vertically stretched, compressed, or neither? Because we have a 2 in front, 2 is greater than 1, so it's going to be vertically stretched. So now, again, I said pick some easy points. The y-intercept here is going to be a little bit tricky because when I go through that process, watch what happens. If I plug a 0 here, minus 5 squared, that is a negative 5 is a positive, or sorry, negative 5. Squaring makes it a positive 25. 25 times 2 is 50. 50 minus 1 is a 49. So my y-intercept is 0, 49. That's a little hard to graph on the graph on this one. So I'm just going to pick a different point. I can go right next to it. If I'm at the vertex at 5, maybe I plug in 4. So I add another page here so I can do that. Okay. So I've got y is equal to 2 times x minus 5 squared minus 1. So let me just plug in like y is equal to 2 times, we'll go 4. 4 minus 5 squared minus 1. This is going to be a -1. -1 squared is 1. So this turns into 2 times 1 minus 1, which is going to be 2 minus 1, giving me just 1 here. So that just means my point, or one of my points on the graph, is the point 4, 1. So I come back to my graph, I can go to 1, 2, 3, 4, and up 1 right there. Again, thanks to symmetry, I know that this point is 1 away. I got another point that's 1 away right there. And again, that's the minimum. That's enough to make my graph. So just make sure you connect those 3 dots, and it's like a little U shape here. Okay. All right. Rewrite the equation in standard form. So if we're going to want to take this vertex form and turn it into standard form, we can. We just have to be careful with how we multiply things out. X minus 1 squared. This is going to be the expansion of x minus 1 times x minus 1. I need to distribute here. So I'm going to take x times x times -1, -1 times x, and -1 times a -1. So when I do that, I'm going to have 4 times. I'm going to put everything in parentheses still. So it'll be x squared, -1x, and -1x gives me a -2x. And then -1 times a -1 is a +1. Okay, the next step here, I'm going to take my 4 and distribute that now. Notice that I made this easier on myself by distributing this first. It is much easier and to keep track of everything there. You'd have to go and rewrite if you want to do the 4 first. Please just make sure you do this part first. So much easier to do it that way. So when I distribute the 4, I get 4x squared minus 8x plus 4, and then plus 9. So I combine these together, I get 4x squared minus 8x plus 13. And that's it. I do the same thing on this next one. I'm going to take x plus 4 multiplied by x plus 4. So that's going to be a -1/2 times in parentheses x squared, plus that'll be 4 times x, and 4 times x is going to give me 8x, and then plus 16. Final step, I'm going to take that and distribute it. So I get a -1/2 x squared, and then I get -1/2 times a +8 is a -4x. -1/2 times a +16 is a -8. And that's it. One last thing to do, let's talk a little bit about a word problem. So we put our vertex form onto real life context like this. So the Tacoma Narrows Bridge in Washington has 2 towers that each rise 307 feet above the roadway and are connected by suspension cables as shown. Each cable can be modeled by this function. So it looks like this as a vertex form where x and y are measured in feet. What is the distance between the 2 towers? So let's see here. Sorry, 1 second on that one. Okay, so we're going to think this through kind of logically here. First thing I want to do is I want to find my vertex. I know it from here and here. My vertex is at the point 1400, 27. So what that means is, should have been a little bit more clear with how x and y are measured, but it's measured in feet, like from here. Like this is basically, we're going to treat this as the origin, 0, 0. Okay, so that means the vertex right here, that is 1400 feet this way. Oops. 1400 feet this way, and then 27 feet up. That's where my vertex is on this in terms of this bridge. So if I want to find the distance between the 2 towers, remember that vertex is right in the middle. So 1400 is right in the middle, then this length here on this side is also going to be 1400. So that means the distance between the 2 towers is 2 times 1400, which is going to give me 2,800 feet. Okay. Was the minimum height of the suspension cable? Again, the goal here is just to put our terminology of like minimums and stuff into the context of this. The minimum is occurring at that vertex. The minimum is the y value. So I have a minimum height of 27 feet. Okay. And that's it. That's all we really need on that question. We don't need to go any further and say that's a minimum height of 27 feet at 1,400 feet towards the middle, but technically that's still accurate as well. And that's it for today. So that's our graphing with our vertex form and understanding some of our important points there and how we can use that to make a graph, but also to analyze some of these word problems based on that graph. All right, but that is it for today. So take care, everyone.